Hello and welcome to this learning video. In this learning video, we are going to take one more problem on the case number 1 for the Fourier series expansion on the interval 0 to 2L. Okay, so let us start with this. So how we can start with? We have to find out the Fourier series expansion for f of x. Not just this, but with the help of that Fourier series for this f of x, we also have to deduce this result. Okay, so how we start with? We start with the given thing. Let given f of x is equal to this. Say this is to be 1, and let f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l plus bn sin n pi x by l be the required Fourier series. In the interval 0 less than equal to x less than equal to 2l. Okay, where a0 is equal to 1 by l integration 0 to 2l f of x dx, an is equal to 1 by l integration 0 to 2l f of x into cos n pi x by l dx, and bn is equal to 1 by l integration 0 to 2l f of x into sin n pi x by l dx. Okay, now this is the Fourier series in the interval 0 to 2l. Now compare this interval with this. We have the interval 0 to 2. Okay, so for the interval 0 to 2, what is the value of l? 1. So you can write cos n pi x by 1 sin n pi x by 1. Just looking at the interval, you can get the value of what? L, because we have the interval 0 to 2l. For this we have the series, and here the given interval is 0 less than equal to x less than equal to 2. So these are 2 is equal to 2l. So L is equal to 1. Simple. Now according to this, now what is the value of L? 1. So 1, this is 2, this is just 1. Putting the value of L to be 1. Simple. Okay, now we just have to find out what? These values a0, an and bn. Okay, so let me give this equation to be equation number 2. Okay, so let us find out a0. To obtain a0, so how one can find out a0? See here, 1 by 1 is 1. So a0 is equal to integration 0 to 2 f of x dx. So this can be written as integration 0 to 1 f of x dx plus integration 1 to 2 f of x dx. Simple. Why I am breaking it as 0 to 1 and 1 to 2? Because the breaking point is 1. Because we have the functional value pi x in the interval 0 to 1. That's why 0 to 1 f of x. And the second value we have in the interval 1 to 2. That's why I am breaking like this. Okay. So what is my a0? a0 is integration 0 to 1 pi x dx plus integration 1 to 2. What is it? Pi into 2 minus x dx. Simple. Now these are elementary integration. You can take pi common. You can take pi common. Integration of x is x square by 2, 0 to 1 limit, plus pi common outside, and this integration of this is 2x minus x square by 2, limits 1 to 2. Simple. Now this is pi, upper limit minus lower limit will give you 1 by 2, so this is 1 by 2, plus pi, upper limit will give you 2 2s are 4, minus 4 square by 2, so this is 2, minus lower limit 2 minus 1 by 2 is 3 by 2. Is it? 2 minus 1 by 2 is 3 by 2. So this is, you can take pi common, so this is 1, so this is pi. Is that the value we are getting? Because you can take pi common, and then 2 minus 3 by 2 is 1 by 2, 1 by 2 plus 1 by 2 is 1. So here I am getting the value of A0 to be just pi. Okay? Therefore, A0 is equal to pi. Now, after finding out A0, let us find out AN. So, what is my AN? AN we have to find out. So, AN is equal to, now I am breaking this AN, 1 by 1 is 1, integration 0 to 1, f of x into what is cos n pi, L is 1, forget to write this. Okay, so f of x into cos n pi x dx, plus then breaking from 1 to 2, so this is 1 to 2 f of x into cos n pi x dx. Simple. Now here you have to apply 2 times integration by parts. So you should have, as I said earlier also, you should have a good hand on this integration. Okay, so A0 is integration. What is f of x? Integration 0 to 1 pi x into cos n pi x dx, plus integration 1 to 2 f of x is pi into 2 minus x into cos n pi x dx. Okay, now apply integration by parts over here and integration by parts over here. So what you will be getting, so applying over this, you can take pi common throughout also, but for the time being let it as it is, pi outside. Then integration by parts for this first function, integration of second. What is integration of cos? Plus sine. Divide by the coefficient of x, limit 0 to 1. Okay. Minus derivative of first. Derivative of first is 1 into integration of this. What is integration of sine? Is minus cos n pi x. Already n pi is there, and again integration of this. So this is n pi is already there, and integration of sine is minus cos, and divide by the coefficient of x. Limits 0 to 1. Okay. This completes the integration in just one line for this first part. Now apply integration by parts for this. So this is plus pi. What is integration of, first function, that's 2 minus x, integration of cos is sine. Integration of cos is sine, limits 1 to 2, minus derivative of this. Derivative of 2 is 0, minus derivative of x is 1. So this is minus 1 into integration of this. So what is integration of this? Minus cos n pi x. Already this n pi is there, and one more n pi would be there after taking integration of sine n pi x. So this is n pi into n pi. limits 1 to 2. Now once you get this, you can able to write the an. This is now simple. So this is same as, what is it, pi. Can you substitute x is equal to 1? So this is 1 into sine n pi. What is sine n pi? 0. So upper limit will give you 0. Minus lower limit is 0. So put x is equal to 0. So 0 into anything 0. So upper limit minus lower limit 0. Now look here. This is minus minus plus 1 upon n square pi square. What about this? Put n x is equal to 1. So this is cos n pi. Cos n pi minus cos 0. This is just the applying limits for this. Now applying limits for this will gives you plus pi. What about this? This is putting x is equal to 2. So look here, when you substitute x is equal to 2, so 2 minus 2, 0. 0 into anything 0. When you substitute x is equal to 1, so this is 2 minus 1, 1, sine n pi. Sine n pi is 0. So again upper limit minus lower limit 0. Okay. This minus minus plus and this minus. So this is minus. Okay. 1 upon n square pi square. And in bracket you can have. So in bracket you can have, put x is equal to 2. The moment you put x is equal to 2 over here, so it will gives you cos 2 n pi. Cos 2 n pi is 1 minus lower limit. Put x is equal to 1. So this is cos n pi. Cos n pi is, okay, for the time being you can just write here cos 2 n pi minus cos n pi. Okay, I am solving here. Let me solve here. We have some space. So this an is equal to, what is it? We can take common this. Okay, pi pi get cancelled. So this is pi pi, this pi get cancelled with this. So this is 1 upon n square pi. Okay, cos n pi is minus 1 to the power n. Cos 0 is 1. Now look here, this get cancelled with this 1 pi and we have minus 1 upon n square pi. Okay, cos 2n pi. Cos 2n pi is 1 minus cos n pi is minus 1 to the power n. Okay, now taking this n square pi square common, so this an comes out to be 1 upon n square pi minus 1 to the power n plus 1 to the power n. So this is 2 times. If you give this minus sign to here, it would be plus plus minus. Okay, so what it should be? 2 times minus 1 to the power n minus 1. Simple. Now after getting an, let us find out bn. Okay, so let me find this bn in a quick time. So bn is this sin n pi x, sin n pi x, pi x into sin n pi x, this again sin n pi x, then pi x into, what is derivative of sin? Minus cos n pi x. Okay, then derivative of x is 1. What is derivative of minus cos? Is minus sine. Okay, here also pi 2 minus x, this is minus cos, derivative of sine, integration of sine is minus cos, and here this becomes minus sine. Simple. Now apply the limits. So this is, just have to remove this. So this is equal to pi into applying 1 in place of x. So this is 1 into minus 1 into minus cos n pi minus 1 to the power n. Okay, cos n pi minus 1 to the power n, correct? Minus, here it gets 0, sin n pi is 0, sin 0 is 0. So minus 0. This entire term becomes 0. Now this completes, plus this pi. Now here 2 minus 2, 0. Okay, so the first term will gives you 0. The second term, 2 minus 1 is 1. Then this minus and minus of the lower limit is plus cos n pi. So what does this n pi gives you? This n pi gives you minus 1 to the power n upon n pi, and this, all these values will get 0. Okay, here also we have n pi. Clear? So this is minus of, so what does we are getting? Bn. Bn, if you can see, pi common, so we remain with minus 1 to the power ny, minus 1 to the power n pi. This is plus, this is minus, so all comes out to be 0. That is Bn is equal to 0. So we are getting Bn is equal to 0. So what you are waiting for then? Substitute these values in this equation number 2 to get the required Fourier series. Still we have to find out this, the second part also we have to find out. So nothing to worry about. Okay, so equation 2 implies this. What was a0? My a0 was pi, so you can write that is 2 implies f of x. What is my f of x? My f of x is pi x 0 less than equal to x less than equal to 1, and we have pi into 2 minus x for, sorry, 1 less than equal to x less than equal to 2. This is my f of x is equal to f of x equal to this, equal to a0 is my pi, so this is pi by 2, plus summation n is equal to 1 to infinity. What is an? An is this, so this is 2 by n square pi into minus 1 to the power n minus 1 into cos n pi x, and we have bn 0, so no need to write anything, 0 into anything 0. Okay, now you just look at the result we have to deduce. Is there a term of cos? No. So what does it mean? It means you have to make the term of cos 1. And how you can do it? By putting x is equal to 0. You can write, put x is equal to 0, we get. Now if you look at this, when you put x is equal to 0, so this value is ruled out. And we have for x is equal to 0, means in this interval we have pi x. And it is also pi into x. So what is x? 0. So you get left hand side 0 is equal to pi by 2 plus summation. You can take here 2 by pi outside. 2 by pi outside, then it is summation n is equal to 1 to infinity 1 by n square minus 1 to the power n minus 1 into cos 0. Simple. Okay. Now cos 0 is, everyone knows, 1. Now take this to the left. So when you take this to the left, you will be getting minus pi by 2 is equal to 2 by pi. And here now you can apply the summation. Put n is equal to 1. So this is 1 upon 1 square. Minus 1 to the power n, minus 1 minus 1. So I am getting minus 2. Plus, put n is equal to 2. So n is equal to 2 minus 1 square is plus 1. Plus 1 minus 1, 0. Plus, put n is equal to 3. So this is 1 upon 3 square into minus 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 2. Plus again 0. Plus 1 by 5 square into minus 2. Plus n 0. Plus and so on. Okay. So we have this. Now you take this to here. So it becomes minus 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 pi square by 4. And here you can take minus 2 common. And we remain with 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. Okay. Taking this minus 2 over here, you can write that is pi square by 8 is equal to 1 upon 1 square, 1 upon 3 square, 1 upon 5 square plus and so on. And this is the result we wanted to show. Okay. So if I am getting my result to be this, which we have to show, that means whatever calculations we have done throughout this problem is absolutely correct. Okay. So I hope this is clear to you. So thank you for watching this learning video and enjoy learning mathematics. Thank you.